Okay, guys, this is the stuff that people struggle with the most is circuit analysis. But if you understand Kirchhoff's voltage and current rule, you also understand how to add resistances in series and in parallel. And the final thing is you understand Ohm's law, V equals I times R. Then nothing here is going to stump you. All right. What we have to do for these circuits today is we have to find the current, the voltage, and the resistance through each component. All right. These are the rules we will lose. This voltage loop rule, that comes from Kirchhoff's laws lesson. The current junction rule also comes from Kirchhoff's rules, which you guys were pretty successful with last week, the people that turned in their work anyway. Ohm's law, that's from before the break. You did a lab, you did an assignment on that, which I have right here and I've marked and I've inputted it. And then just last week, towards the end, we did resistors in series and we did resistors in parallel. So these are the 5 tools you need with you to do these. So I would suggest you pause the video here, write these down to begin with so that you know which formulas you're going to be using to solve these circuits. So the rest of the lesson now is just giving you some circuits to solve. Now let's see, how am I going to do this? Because we have to make a table for each of these. So let's see if I can move that over to there. Put it in, no, I can't do that. All right, that's fine. Let's move that over to there. And then I'll get out my notepad on the other side. There we go. So it's going to be a little bit awkward because you're going to have to look down here at these circuits. But it's not that big a deal. Just going to go here and discard my changes. There we go. So I'm just going through the PowerPoint here in the slides, and there's our first circuit there. I'm not sure if I can zoom into that very much. Maybe a little bit, that's okay. And yeah, we'll just go from there. So my first circuit is just a simple series circuit. The voltage at the source is 30 volts, and the 3 resistances are given 12, 8, and 10 ohms. So the way that we solve this problem, and the way that I solve that is I go R1, R2, R3, R4, not R4, and RT. And we have to find the voltage, the current, and the resistance through each of those components. And we solve it, we express our solution in a table like this. The RT, that's at the source, right? I don't know if you remember that from before, but it's at the source. So at the source, we know we have 30 volts. And we know all the resistances. R1's resistance is 12 ohms. Then we have 8 ohms. Then we have 10 ohms. The rest of this is, can you fill in all the blanks? So the first thing I can see, a lot of this is identifying what can you find first, and then it gets easier the more stuff you have. So first thing I see we can do is we have 3 resistors in series. When you have 3 resistors in series, then you can get the total resistance just by adding the individuals. So it's 8 plus 10 plus 12, which is 30 ohms. You know, if we put at the top here that that's measured in ohms, the current is in amps, and the voltage is in volts, then that should be good for us. Now, anytime you have 2 things, you can get the third thing. So if I have at the source 30 volts and 30 ohms, then I can always use Ohm's law to find the current, which is going to be V over R, which is 30 over 30, which is 1. All right. Now, if you want to write that down, go ahead and pause it, but I'm going to erase it so give myself a little more space here. I might need it eventually. Um, moving right along, if you remember Kirchhoff's current rule, and I'm going to move fairly quickly here, so feel free to pause this if you want to try and figure it out yourself. But next, I'm going to use Kirchhoff's current rule, which says that if there's only one path, then the current will never split up. So it's going to be 1 amp the entire time. There's no spot for it to break up or come back together. And then finally, if we just go across, I'm just going to switch to green here for no apparent reason. V is equal to I times R, just going back to Ohm's law. So 1 times 12 is 12, 1 times 8 is 8, and 1 times 10 is 10. And we're done this circuit. We are done this circuit. That's how easy it is to solve a simple series circuit. Of course, we're going to get more and more difficult as we go. And yeah, we're gonna figure that out. Second circuit here is a parallel circuit. And we're going to move down, and I'm going to draw a new table. I'm going to draw it in. I feel like I want to draw it in black, but we'll see. Maybe blue. So the next one's got 3 resistors again. So I make R1, R2, R3, and R total. My R's are a little lackluster here. That's okay. V is measured in volts, I is measured in amps, and R is measured in ohms. And I make my table. I write in the things that it gives me, and it gives me the 3 resistances. It gives me a 5 ohm resistance, a 3 ohm resistance, a 4 ohm resistance. It also tells me that there are 12 volts at the source. I'm going to need to track down my calculator next, which is right here, because I see again, the first thing I can do is I can add up my resistances, but they are all in parallel. So if you recall, resistance is in parallel. 1 over RT is equal to 1 over 5 plus 1 over 3 plus 1 over 4. I don't like the way that looks over there. I'm going to write it right here. All right, it's going to be 1 over RT is equal to 1 over 5 plus 1 over 3 plus 1 over 4. There we go. So we punch that into my calculator just to review. This is one of the skills you were supposed to pick up last week. 1 over 5 plus 1 over 3 plus 1 over 4 equals, it gives me 0.783. But then that is not the answer to the question. That's what 1 over RT is equal to, 0.783. Actually, it's 3 repeat. So if I want to find what RT equals, I have to find that inverse, that reciprocal button on my calculator. It's x to the power of -1. So I take that 0.783 that's on my calculator, I hit that button, and it gives me a total resistance of 1.3 ohms. That is rounded. I got a bunch of digits on my calculator, and I rounded it to 1.3. So I'm writing that in as my total resistance. Now we're back to here. You can pause the video if you want, because I'm going to have to figure out more things, and so I need some space again. I hope that a few of you will catch on at this point. Again, anytime you know 2 things, you can find the third thing just by using Ohm's law. I equals V over R. So that's 12 volts divided by 1.3 ohms is 9.2 amps. And now we got to think. I got to go back to my diagram and try and figure out, all right, so what can I figure out next? And the next thing to figure out is the voltage drops, because the voltage rule, which we haven't used yet, says that in any one path, and I just drew a path there, I'm going to erase the other one. I drew a path there that hits one resistor and then through the source, goes through the source, then one resistor, through the source, one resistor, through the source, one resistor. So if it gained 12 volts at the source, how many volts did it drop at that one resistor? And the answer is 12 volts. 12 volts. All right, apply that same logic to another path. If I go this way through this path, how many resistors do I hit? Just one, just R2. So how many volts did I drop there? 12 volts, and then just apply the same logic to that last path through R3. So now I've got all the voltages, and I can find the currents just by applying this formula here again. 12 divided by 3 is 4, 12 divided by 4 is 3, and 12 divided by 5 is 2 point something. I don't know. It's 2.4. And then this circuit is solved. That's how you do a series circuit, parallel circuit. And now we're going to do combination circuits. These will be the toughest ones that you have to deal with. Let's move down a little bit. Let's erase this stuff. Let's erase this stuff. And there we go. Send it to the trash. And this time I have 1, 2, 3, 4 resistors. So I'm going to go R1, need a little more space than that. R2, R3, R4, and don't forget about R total. V, I, and R at the top. Here's our lines. You should be drawing these tables. Pause these videos so you can make the tables. If you're a little slow catching on to this, then even just being able to draw the tables might be a win for you at this point. So I'm going to switch to blue here to fill this in. Start by filling out everything you know. I know there's 6 volts at the source. That's right there. And I know all the resistances again. It's a 3, it's a 2, and it's a 1, and it's a 1. All right. So just like before, and you're going to need your adding resistor skills here. Go ahead and review that lesson if you need to, okay? Because we got to look at this combination circuit and figure out how to put these resistances together. I'm not going to spend a lot of time reviewing it here. So 1 and 1 in series makes 2. 2 and 2 in parallel makes 1. And the way that you figure that out, I'll just back out here for a second, is, all right, so what did I do there? I took that circuit. I still got this circuit here, or that resistor, and that resistor. So this was a 2. Now this is a 2 because I added the 1 and 1, and this is a 3. So I got 2 and 2 in parallel. So that means 1 over R for those two is equal to 1 over 2 plus 1 over 2. If you do the math there, you're going to find that R equals 1. So now, again, if I'm going too quick, just pause it. Now I've got this circuit here. I've taken the 2 and the 2, and I've made it into one resistance of 1. Well, now I just have 1 and 3 in series. So my total resistance for this circuit is just 4. 3 and 1 is 4. So I go back up to my circuit here. Total resistance is 4. 6 divided by 4 is 1.5. And now I got to think. Now I got to think again. Now I have to think again. So 1.5 volts or amps leaves the source. They split up. Some of it go through R2 and some of it go out through R3 and R4. Let me just erase my stuff here so you can see that a little better. So some of it's going to go that way, some of it's going to go that way. But they're going to join back up at this junction and go through there. So through R1, I'm going to have 1.5 amps again. And then I just got to go 1.5 times 3 is 4.5 volts. I think maybe I should check that on my calculator. I think that's right. 1.5 times 3 is 4.5. That's just using V equals I times R. That's just arranging that formula to solve for V. All right, now I got to think again. I'm going to erase my old arrows, go back through this circuit. So I got the current leaving the source, and I'm just going to focus on this shorter loop right here. Gain 6 volts at the source, and it hits R2 and R1. And it drops 4.5 volts right there. How many volts does it have to drop at R2? Remember, the voltage gain at the source has to equal the sum of the voltage drops in the path. So if it dropped 4.5 at R1, then it must have dropped 1.5 volts at R2. I know two things, so I can find the third thing. 1.5 divided by 2 is 0.75. And then I got to think again. I'm going to erase my thinking over here, pause the video, go back if you don't understand what I've done there. And all right, so I'm going to start thinking about current. All right, I got 1.5 amps that come from the source. That's from that original current. We just calculated that 0.75 amps came up through R2. So how many amps went up and around through R3 and R4? 1.5 got to the junction, 0.75 went that way. How many went the other way? Well, if you take 0.75 off of 1.5, you're left with 0.75. Now, if you're extremely clever, you might know why it split up evenly in those two paths. It's because the resistance in this path is 2 ohms. The resistance in this path is 2 ohms. And that's why the current broke up 0.75 and 0.75. Anyways, we can finish this off very easily. 0.75 times 1 is 0.75 volts. 0.75 times 1 is also 0.75 volts. And then this circuit is complete. We are done. Let's move down some more. Pause the video, go back if you didn't understand that. We're getting there. We're getting there. This one, again, it's the same diagram, but we know some different things. Some people might think this is easier. Some people might think it's harder. But I've got R1, R2, R3, R4, and the total. So here's my table, and what do I know this time? At the first resistor, at R1, I know that there's 6 volts, and I know that there are 3 ohms. At the second resistor, I know there's 4 ohms and 1.5 amps. At the third resistor, I know it's 2 ohms, and that is all I know for this circuit, which, I don't know, to me, it actually makes it a little easier, especially for anybody that does not like adding resistors in series and parallel. We won't have to add resistors here. We just have to use Kirchhoff's current rule and voltage rule. And Ohm's law. To begin with, we've got 6 and 3. I equals V divided by R. 6 divided by 3 is 2. V equals I times R from Ohm's law as well. 1.5 times 4 is 6. And then away we go. And then I look back to my diagram. All right, what does that tell me? Well, I'm going to first take the path that goes right here, just like before. And what did we just figure out? There's a 6-volt drop at this resistor, and there's a 6-volt drop at this resistor. So how many volts were gained at the source? 12 volts. 12 volts gained at the source. That's the only way to make that happen. All right, erasing my thinking. If 1.5 amps came through this resistor and they're coming around like this, then how many amps went through the source? Actually, that's not 1.5, that's 2 amps. If 2 amps came through R1 and they go back around into the source, then how many amps went through the source? And the answer is 2 amps. There's no place between here and here for the amps to break up. All right, that helps. That's something. And again, we can use Ohm's law. 12 divided by 2 is 6 ohms. And then we have to think again. So let's follow that 2 amps thing. The 2 amps come from the source, 2 amps right here, and they break up. How many amps went this way? Well, 1.5. All right, so this time how many amps go around and take that other path? If 2 amps get to the junction and 1.5 went straight up on the first path, then 0.5 amps went that way. It's not a 6, that's a 0. 0.5 amps go that way. So it's 0.5, 0.5. V equals I times R, so 2 times 0.5 is 1. All right, I'm going to erase my thinking. Pause, go back. If you don't understand, watch it again. So now if I use the voltage rule and I go around, take the long path, we know that there's a 12 volt gain at the source, 6 volts drop in that resistor, and we know one of the other voltage drops, right? This is a 1 volt drop at this resistor. So how many volts drop at this unknown resistor, at R4, at that unlabeled R4? It's got to be 5. Because 5 plus 1 plus 6 equals that 12 volt gain. V divided by R, 5 divided by 0.5 is 10, I believe. You can use your calculator and correct me if I'm wrong on that one. That is how you solve that one. There are two more on here, bigger ones, and I think I'm going to do them in a separate lesson, maybe on Thursday, because all I really want you to do this week is get awesome at solving circuits. All right, I have 6 circuits that I want you to do attached here. If you can get 3 done today, let's say the first 3, and then the other 3 done towards the end of the week, then you'll be all good. There's actually 8, not 6. The last 2 I'm not officially assigning. They're just, if you're catching on to this really quickly and you're not being stumped on any of these, then go ahead and try those challenge ones at the end, but they're very difficult. And I'd be happy to help you out with them. If you email me and ask for some hints, I'll get you started on it. Even to solve them myself, I have to redraw them because you'll see they don't have these nice right angles that most of our circuits have. They're all kind of all over the place. Anyways, so let me know what you think of that. You can see over on the left that there are some other circuits that we didn't get to, but those 3 I'll post in a different lesson. I think you have enough information now to do the first 6 circuits, which is what I'm officially assigning for the week. How do I want you to submit this assignment? Well, you could make a Google Doc and put in tables and fill in the tables. That would be a nice clean way of doing it if you're comfortable doing that. The only other way to really do it is to draw the tables on a piece of paper, fill them in. If they're right, great. And well, obviously you're gonna have to take a picture of them and submit them. All right. So that's all I have for now. And good luck with that. Keep the emails coming if you guys have any questions. You can get, if your parents have questions about what we're doing or anything, also get them to email me. All right. That's all for now.